Okay, today we are going to be solving radical equations. A radical equation is just an equation that has a variable in the radicand or a variable with a rational exponent. The difference between equation and an expression is the equal sign. So here we have examples of radicals in different forms. Steps to solving radical equations. First thing you're going to do, and it's very similar to solving absolute value equations because you're going to isolate the radical expression. You're going to square both sides, cube, take it to the fourth power, whatever the index of the radical is. Solve the equation for the variable, plug and chug to check for any extraneous solutions. A reminder, an extraneous solution is an answer for a radical equation that algebraically works, but when you put it back or plug and chug it into the actual original equation, it reproduces a false answer. You must always plug and chug or check for false solutions. How do I eliminate exponents? With the following. Well, if you have something that looks like this, if we recall, when we take a power to a power, we multiply. So if I can figure out what to multiply this, what to take the power to take this to, I want to equal 1. I want 2/3 times something to equal 1. Well, the reciprocal of 2/3 or 3 over 2 equals 1. That gives me 6 over 6, or x to the first power equals, and this would be the square root of 6 cubed, which is just 6 square roots of 6. And don't forget, when you're square root, you have a plus or minus, so there's two possible solutions. Here, when you're solving something that looks like this, we're first going to get the radical by itself, and then we're going to take the square root of x cubed equals 3. To square opposite of square root is a square, so we're going to square both sides. So I have x cubed equals 9. The opposite of cubed is cube root, so we're just going to take the cube root of both sides. Do that in a different color so you can see it. So I have x equals the cube root of 9. And these examples, normally I would check them, but for right now, I just wanted to show you how to get rid of something that looks like this and how to get rid of something that has a rational exponent. Something to remember when solving radical expression or equations, when you take the square root of both sides when solving the equation, you have two possible solutions. If I look at the original, x squared equals 9, x could be 3 or negative 3. So our solution when you take a square root of both sides is 3 or negative 3. We have two possible solutions. We're going to go ahead and review solving absolute value equations because we're going to use absolute value equations when we take the square root of both sides in solving radical equations. So if you remember, absolute value means we're just measuring distance. We're measuring the distance of whatever's inside of this. So there's two numbers that have a distance of 10 from 0. It's 10 and negative 10. So what we can say is this inside could equal 10, or 3x minus 4 could be negative. Because if I made this negative, it could also be 10. We're going to solve both. So I have 3x equals 14, divided by 3. On this side, distribute. So I have negative 3x plus 4 minus 4. Then I have negative 3x equals 6 divided by negative 3. X equals negative 2. When you solve absolute value equations, you always have to check your solution. So we're going to take 14/3 and plug it back in. This just cancels. I have 14 minus 4 equals 10, which gives me the absolute value of 10 equals 10, which is true because 10 equals 10. When I plug negative 2 in, I get the absolute value of 3 times negative 2 minus 4 equals 10. So I have negative 6 minus 4, absolute value of negative 10, which is 10. So both of these solutions would work. That's how you solve absolute value equations. And we're going to use that later on to solve radical equations. Now, how to solve this square root equation? First step, I have to isolate the square root. So I'm going to subtract 3 from both sides. So I have the square root of 2x minus 3 equals 5. And we remember, what's the opposite of square root? Squared. So in order to get rid of the square root, we're going to square both sides of the equation. This is going to cancel. I'm left with 2x minus 3 equals 25. 5 times 5. And then just solve the equation like you normally would. So I have 2x equals 28. Divide by 2. X equals 14. And don't forget, when you solve square root equations or radical equations, you must check your solution. So let's go ahead and check our solution. Put it back into the original equation. 14 in for x. So I have 3 plus the square root of 2 times 14 minus 3 equals 8. 3 plus 28 minus 3, which is 25, which is 3 plus 5. 8 equals 8. And that checks out, so 14 works. 14 is not an extraneous solution. Let's solve another one. First thing I have to do is isolate my rational exponent. So I'm going to divide both sides by 3. I'm left with x plus 1 to the 2/3 equals 4. Now, in order to get rid of this, and we all talked about this on the second slide, is we have to take both sides to a power so that I can multiply the powers to get 1. So I would use the reciprocal of 2/3, which is 3/2. So I'm going to take both sides to the 3/2 power. As soon as you do this, 2/3 times 3/2 is just 1. So I have x plus 1 to the first power, or just x plus 1, equals 4 cubed, the square root of 4 cubed. Oh, I don't need that if I'm doing square root. 4 cubed is 64. Now, here is the important part you need to understand. What we just did was we solved the equation by finding the square root. So we need two possible answers. We need plus or minus. But instead of using plus or minus, since we haven't actually solved for x, we're going to go ahead and use absolute values so that we can say this right here is either going to be positive or negative, which is going to end up being 8. So my two equations, x plus 1 equals 8, and negative x plus 1 equals 8. Solve both equations. Getting ahead of myself. So x equals negative 9. Now remember, once we have our two solutions, we have to go ahead and check and make sure we don't have an extraneous solution. Let's go ahead and do that. I'll use a new page to check. So I'm going to plug in 7 up here. So I have 3 times 7 plus 1 to the 2/3 power equals 12. So I have 3 times 8 to the 2/3 power equals 12. 8 squared is 64. So I have the cube root of 64, which is 4. 12 equals 12. Works out. Okay, let's go ahead and check the other one. So we know that 7 works. X equals negative 9, so we have 3 times negative 9 plus 1 to the 2/3 power, 3 times negative 8 to the 2/3 power. Now, if you're not sure how to solve that, go ahead and plug it into Desmos, or use a calculator, or you can just say negative 8 squared, the cube root of negative 8 squared, change it to your radical form. Which is the cube root of 64, which is 4, which works out. And I ran out of room. So both of these are solutions to my radical equation. Let's try another example. What is the solution? Well, first thing I have to do is isolate the 5th root here. So I have to get rid of the plus 1 and the divided by 3. So we're going to subtract 1 from both sides. So I have 3 times the 5th root of x plus 1 cubed equals 24. Divide by 3. So I have the 5th root of x plus 1 cubed equals 8. Now how do I get rid of, what's the opposite of 5th root? 5th power. So we're going to take both sides to the 5th power. Now, if you want to plug that into a calculator, 8 to the 5th, you can, but I would leave it for just a second. I would just leave it 8 to the 5th. because we have to take the cube root of this, because the opposite of cube is cube root. When I take the cube root, it's going to simplify that, and I won't need a calculator. I'm going to use a different color for that. So I take the cube root. Cube root of a cube cancels, and we don't need a plus or minus since my index of my radical is an odd number. So I have x plus 1 equals the cube root of 8 cubed times 8 squared. Rewrite it like this so that we can simplify. The cube root of 8 cubed cancels, and I take out my 8. So I have the cube root of 8 squared, and we know what that is. We just did it on the problem before. 8 squared is 64. The cube root is 4. So I have 8 times 4. Subtract 1. Oh, not yet. Getting ahead of myself again. So I have 32. Subtract 1. So I have x equals 31. Now, before you move on, make sure you check your solution. So I'm going to go ahead and plug 31 in here. So I have 3 times the 5th root of 31 plus 1 cubed. And then outside of the radical, I have plus 1. So I have 3 times the 5th root of 32 cubed. Plus 1 equals 25. Now, if you remember how to solve this, you can use Desmos, or you can just say, okay, this is 32 times 32 times 32, which is 8 times 4, or I'm sorry, 8 times 4, 8 times 4, 8 times 4. Yeah, that's right. So I'm looking for perfect cubes here, or perfect fifths. So I'm not there yet, but I can see I'm getting close. I'm going to have some 4s. So I have 4 times 2 times 4 times 4 times 2 times 4 times 4 times 2 times 4. So we have, there they are. Now, be careful here. 2 times 2 is 4, and then 2 times 2. So I have 3 2's, but I also, if you look, I have 1, 2, 3, 4, 5, 6 4's, so I can get rid of 5 of them because I have a 5th root. So I have 4 to the 5th times 4, but then look how many 2's I have. 1, 2, 3. So times 2 times 2 times 2. So I have the 5th root of, this one cancels, 2 times 2 times 2 times 2 times 2, which is 2 to the 5th. So technically I have 4 times 2, which is 8. 5th root of 2 to the 5th is 2. 4 times 2 is 8. So I have 3 times 8. I'm going to finish my equation here since I solved without finishing it, or simplified. So I have 24 plus 1 is 25. Now, you could also use Desmos if you wanted to. If you look, I also plugged in the 5th root of 32 cubed. Where do you find the 5th root? If you click functions, and then over here, I can't see that. Let me see here. Over here under MISC, right here is your 5th root. Now, we are going to, so 24 plus 1 is 25. 25 checks out. Now, this is a lot of work. If you want to use Desmos, that's fine. But we came up with the correct solution. Now let's look again at the next one. Another example. So I'm going to go ahead and solve. Now let me give you a hint. When you have an equation with a variable on both sides of the equation, most of the time you're going to have an extraneous solution. Not always, but most of the time. So make sure you check for extraneous solutions. So for here, I'm going to add 5 to both sides, and then I have the square root of x plus 7 equals x plus 5. Then how do I get rid of a square root? Squared. So here, the square root and the square cancel. I'm left with x plus 7 equals x plus 5 times x plus 5. So x plus 7 equals x squared plus 10x plus 25. All I did here was FOIL and combine like terms. Now, to solve a quadratic, I'm going to subtract x, subtract 7. set it equal to 0. So I have 0 equals x squared plus 9x plus 18. So when you solve a quadratic like this, you can use a quadratic formula, you can graph it and find zeros, or you can factor. I know that this one can be factored because two numbers that multiply to 18, that add to 9, 1 and 18, 2 and 9, 6 and 3, or 3 and 6, or 6 and 3. So I have 0 equals x plus 6 and x plus 3. So what variable or what values for x would make this true? -6 and -3. Now we have to go ahead and check for extraneous solutions here so that we can make sure that we don't have one. Make sure both of those work. I'm going to plug in -6 first, so I have the square root of -6 plus 7 minus 5 equals -6. -6 plus 7 is 1. The square root of 1 minus 5 equals -6. So I have 1 minus 5 equals -6. -4 equals -6. Does not work. So that is one of my extraneous solutions right there. Now go ahead and plug in -3. So the square root of -3 plus 7 minus 5 equals -6. Square root of 4 minus 5, 2 minus 5. Hold up, what did I do? Oh, not -6. It equals x. X is -3. My fault. I was going to say we have two extraneous solutions, but not possible because this is actually -3. If you look at the original equation, it equals x, and x was -3. So my only solution to this would be x equals -3. -6 would be what we call an extraneous solution. Now the final example that I want to show you for sure is something that looks like this. All right, we have 2x plus 5 to the 1/2. Now, be careful when you solve these because this is technically the square root of 2x plus 5 equals -10. Is it possible to have a negative answer when you find the square root? What negative number squared is going to give me an answer? There is none. So when you have something that looks like this is no solution. Don't solve it. This is not possible. So make sure you pay attention.